So there is a second technique that we'll do, and that will be exactly random. So I say my action is random. I just take a random action, and this one is, of course, is called as exploration. So every time I select a random action, and believe me, your agent will still learn. So you go 20-30 times to the boys hostel mess, it serves you great food, you learn that this food is good. I go to my favorite restaurant, you learn that it does serve good food, not as good, so you learn the QSA value. You go to a random restaurant which is terribly bad, the one aside your hostel, you go 100 times, all 100 times it serves terrible food, so it's bad. You go to another restaurant which gives you bad food, so it's again bad, and hence you realize that okay, boys hostel mess is the best food to take at Allahabad. I wish that was true, no offense to girls hostel, same vendor serves there. So you try everything possible, and that's how it learns. So that's completely safe. So I started off with this, I was getting 100, but then I started taking this. I took it 20, 30, 40 times, and this value kept on increasing. So same equation. So these value kept on increasing, and because these values kept on increasing, it became minus 20, minus 10, plus 10, plus 50, plus 80, plus 150. And then I know that this one is actually bad. However, when I took this one, it kept decreasing. So it kept decreasing till minus 25. This also decreased to minus 120. So I'm trying everything possible. And because I'm trying everything possible, I can never go wrong. That's the safest, best technique possible. You can never go wrong. And that actually happens with restaurants. So you are sitting with your friend, and your friend says, let's try this new hotel. Excuse me, I've had food 20 times over there. It's terrible. I'm not going. Okay, let's try this new restaurant. Eaten there 30 times. Bad. Let's try this one. Fresh into the city. Eaten there 40 times. My favorite. That's the one. So, you know everything about everything. You know absolutely everything about everything. And because you know everything about everything, you always take in the best actions and the best choices possible. So, is that the best thing on the world? Unfortunately, no. So, let's take exactly the same example and say that my random, which was initially a minus 20, and this one, let's say, was minus 100, minus 150, minus 35, minus 40. I applied this. So this is the state 1, this is the state Q2. So I say Q22. I select the action right. So the old value is, the new value is old value, which is a minus 20 plus learning rate times small learning rate. Observed from minus 20, I took a right. What did I observe? From minus 20, I took a right. I don't collide, so there's a small margin of reward that I get, plus gamma times maximum of A dash, all these values. So the best is minus 35. Minus the old value, which was minus 20. And now what you'll see is put in a 0.9 learning rate, put in a 0.9 this thing. You'll see that it'll reduce even further. So I took the right action. This was the best one. It leads straight away to the goal. But instead of this minus 20 increasing, getting better, it's becoming worse. What happened? The values here entirely depend upon the values here. So unless I learn this thing, I cannot learn this thing. Unless I get good estimates for this, I cannot get good estimates for this. Unless this is good, this will not be good. So I first need to basically learn this, and then this. Otherwise, you end up behaving that this minus 20 you took a right, it's very bad. Now imagine what happened. This was a boys hostel mess, best place. In reality, God knows it. However, you tried it once. Unfortunately, you had a very bad experience because the state that it landed you to, it was a new mess. So nobody knew each other. It was still in its infancy. So the ambience wasn't very good. The chefs weren't very trained. The administration stuff were being settled down. It had just operated. So because it wasn't very good, I go there, I get a bad taste. Now I'm never gonna believe that Boys Hostel Mess is a good place. And I keep on believing that my favorite restaurant is actually the best, which is bad. So that's another weird problem that doesn't come in supervised learning. It doesn't come in unsupervised learning. It comes in sequential learning. Any sequential learning has this problem that your learning targets are dependent upon other states, who are dependent upon others, who are dependent upon others. Eventually, some will dominate, like goal is constant, so the neighbors are more or less stable. And that is how the learning eventually happens. As of now, the problem is that even though I took a great action, I got a bad taste, so I'll have to take it a number of times. So, how much do you expect that in exploration I need to try out for every state? So I need to visit every state action pair once, so the state space times the number of actions. If I'm near the goal, probably 10-20 times is enough to get all the probabilities. If I'm little further apart, probably 1,000 times. If I'm very further apart, probably square of state space size is a good number. So I'll have to try too many times. Most of the times my neighbors have not learned. And because my neighbors have not learned, my S dash has not learned, it's unreliable. Like this minus 22 was absolutely unreliable. So, summarizing it up around over here, so there are two techniques that I could try, exploration and exploitation. The problem with exploration is that I require too many tries. So it does learn, but learns very slowly. And that is exactly what would happen. Restaurant example. You've tried every restaurant 100 times. Every restaurant wastes 1 day, so you would have probably extended your degree. You cannot do that at Prayagraj with the current degree program, which is 4 years. So trying every restaurant 100 times, you'll need a lot of money. I'm not sure where is that coming from, but you will need a lot of time as well. On the other hand, of course, I have exploitation, so it of course learns too quickly, which is good, but it gets stuck at a local optima. And I don't tell you what is a local optima. So, everybody has done the machine learning course, you know that. And in this case, you can imagine a local optima like me trying this thing every time. So I'm stuck with this plan. Every time I take this plan, I'm stuck at a local optima. So, in reality, I cannot use either of them. I cannot use exploration. I absolutely cannot use exploitation. So, I should be able to really do something which is intermediate of it. And because I need to do something which is intermediate of it, I try to mix and match. I'll just summarize the discussions around by another example. So, suppose these were the four restaurants called as up, down, right, and left, and they initially had some random values. Let's give the same random values. You try the action left, you have a pretty bad experience, so that's clearly bad. That's -10. It's a bad experience. You try the action right, you somehow had a bad experience. You try up, you have a good experience. Let's also try once the other one, and suppose you actually have a very good experience. Now, intuition suggests that you tried all the restaurant once, so the initial randomization problem may not be that important. So you try this restaurant again and you start losing out. So you try it a few times and you start losing it out. You stop lost confidence. So you try this one and it turns out to be better every time. And therefore you try to end up in taking this one again. What really happens is that this was my boys' hostel. So I may have a bad experience once, I may have a terribly bad experience the second time. Looking at it, honestly, nobody's gonna go to this restaurant back. Twice bad experience. Look at it, this is reducing, but it's still much better than this. It's improving, it's still better than this. Twice I had bad experience because my neighbors weren't learned. I don't care if my neighbor wasn't good. I may have landed at the wrong state. I didn't even take that. You take a right, and sometimes what happens is that the neighbors are learned. You take a right, but instead of taking a right, instead of going here, you end up going here, which is very bad. So sometimes neighbors are learned very well. Everything is learned very well, but you end up slipping. 5% chance of slipping, you end up slipping. So the first time that I went to this boys' hostel mess, I unfortunately had the bad experience. The neighbor wasn't learned. The second time I thought I was at boys' hostel mess, but God had landed me into a different place, the girls' hostel mess. That's actually bad. So that's actually bad. So the experience is genuine, but it's of a different mess. God landed me at the wrong state. Intuitively, you're never going to try that, but then just in case you would have tried it once more, maybe you would have the neighbors learned, God was also kind to me, and maybe another time everything would have been okay, and maybe another time everything would have been perfect. Now, would you take this risk? And that's a good question. Would you be taking this risk? Because intuition says twice if something is bad, you just say it's bad. If you take another once, it turns out to be bad, everybody's gonna laugh at you. Of course, in computing, you're gonna waste time. But if you take that risk, you try it once more time, maybe first time neighbors won't learn, maybe the second time God landed me at the wrong state, nothing else was wrong. In reality, it was actually very good. This is a critical question, and that's what we'll try to answer when I try to mix exploration with exploitation. If you, in the mixture of exploration and exploitation, if you end up in being too explorative, you're taking too much of a risk, so you don't get good returns. Things are bad, they continue to be bad. So you lose time. However, sometimes what happens is that If you go too much into exploitation, so you're saving a lot of time, but the best is not even seen. Funny thing, that's what happens in tests. So how many tests do I take? 5, 6, 10, 20. If I take too many, you know the problem. I end up wasting too much of time, mine and yours. You would have better watched a movie, but I'm trying to ensure that the grading is genuine. If I take too less, then luck becomes important. And especially working out with you people, some great students, they just don't perform on specific days. And if it turned out to be that specific day, then I mean the person will lifetime have that great card to less evaluations. Luck wasn't favorable. It's a part and parcel of every life. So let's just try to trade off between exploration and exploitation. So I have strategy 1, and strategy 1 is as simple as that I explore every SA pair n times and exploit thereafter. So you try every restaurant 10 times, after that you're like, I'm done, I'm not gonna try. So my action selection is of course gonna be given by either a exploration, which is a random of A. This is if count and otherwise of course it's arg max E. I'll just say it formally rather than write it formally. So you've got multiple SA, of course. So if the count of all SA pairs, so it's for all A, if all of them have been tried at least n times, then you just take the argmax. If there is even one action A which hasn't been tried n times, even if there's one such action, then you try the random out of all the actions A which haven't been tried n times. So random out of all the actions A which haven't been tried n times. Okay, so intuitively just select an action which hasn't been tried n times and out of all of them apply it randomly. Bad strategy because of course we know this n is impossible to set. There is no sane way by which you could set this n. And the problem is also that n ideal value depends upon the state. And because it depends upon the state, some states are very stable, so you get convergence very early. Some states, they depend upon too many states and their actions of actions and everything. So they converge very slowly, and that depends upon this, that decides this parameter n. So bad strategy. I'll take strategy 2. And my strategy 2 is of course that I'll make it parameter free. So what I do is I take a roulette wheel and it has up, down, right, left, and the circumference of this roulette wheel is proportional to its Q value. There is, it's a funfair kind of thing. So there's a pointer like this. Then you spin this roulette wheel and whichever action gets selected. So That's the cartoon form of it. You spin it, and after the roulette wheel pauses, then whichever does the arrow point to, that's the one that you actually select. In simple, this is called as the probability of the selection of the action A, given that you are at a state S, is given by the Q value of the particular action, and you normalize it up. If you are a bit too mathematical, which I hope you are, you will understand that I need to actually apply a softmax. So I need to actually apply in a softmax because the Q values could be in absolutely any range possible, and because the Q value could be in absolutely any range possible, the probabilities unfortunately cannot be negative. So I just apply a softmax over it, and because I apply a softmax over it, I get an output which is strictly positive or zero if you have minus infinity, and therefore the probabilities are taken care of. So intuitively this, but then mathematically a softmax. There is a third one. This one is called as the epsilon greedy. So all that you say is that you are greedy epsilon times and non-greedy 1 minus epsilon times. So the action is equal to random if, and you are exploitative, and R is just a small random number between 0 to 1, and epsilon is a small constant. It simply says that you say that I am explorative 10% of the time. So 10% I just apply a random action, 90% of the time I'm exploitative. And that's practically what happens, at least when I decide restaurants or food from a menu. My strategy is absolutely very simple. So all that I will do is I'll say that, okay, so today I'm feeling like exploring things up. I'm in a good mood. Let's try a new restaurant. Let's try something new. Let's try a new food. In games, let's try something that I haven't ever done. Normally, I'm not in a very good mood, so 90% of the time, I'm like the same old things, the same old restaurant, the same old food, the same old things. So that's what's called as epsilon greedy, and I mean, that's practically what you do most of the time. So one of the widest known strategies, epsilon greedy, and how do you select the action. And of course, epsilon could also be made adaptive with time. You start off with more explorative and you end up being more exploitative. So you start off with being a higher value and you end up being a lot more smaller value. So in short, this is pretty obvious thing to do. So you first use epsilon greedy like algorithm to just select an action. The Q table is random. And once you select an action, you make that action and you observe and you learn that. The Q table improves a little bit. Then you select another action, the Q table improves. You select another action, the Q table improves. The interesting thing is that your Q table keeps improving. That keeps improving the action selection. That keeps guiding the learning so as to reduce computation time. So till you're learning good, what happens is the Q table becomes a better representative which guides an effective good action selection. If you happen to exploit too much, you will still learn, the convergence will be observed, but then the only problem is you'll converge into a local optima. If you try to be too exploitative over here, it will still learn, the learning will be absolutely immensely slow. And that is how we really need to make this algorithm work out. So, sounds good, sounds cool. In reality, it's actually a lot better, because if you given any generic map like this, where the action selection is initially little bit okay, so what happens is that it might not even explore areas which are very far by, which clearly are not into the alignment to the goal. So Q learning, it effectively may not even explore the complete map. It may not even visit all the states, which is good for me. And because it may not even explore all the states, forget about value iteration loop on S, policy iteration loop on S. Here also I'm just taking actions and learning, but some states which are completely unreachable, completely bad, they may not even be reached even once. So my computation time also gets a bit limited in that sense.